In this video, I will be evaluating this circuit that has a sinusoidal input of 10 volts peak to peak and a frequency of 60 hertz. It has a couple resistors, R1 100 ohms, R2 400 ohms. And I'm going to find the period T, the volts in RMS, the peak to peak voltage across resistor 1, and the peak to peak voltage across resistor 2. And I will also be finding the RMS current and the frequency out. So now let's find the period. The period T equals 1 over 60 hertz. So I get my calculator out and I go 1 divided by 60 hertz equals 16.666 milliseconds. So the period is 16.666 milliseconds. Okay, so what's the period? The period is the amount of time it takes to create the sinusoidal form. Now, I'm going to now find the volts in RMS. The volts in RMS equals a 10 volt peak to peak over 2 times the square root of 2. That equals 5 volts peak divided by the square root of 2, which equals, I'm going to grab my calculator again, 5 divided by square root of 2 equals 3.535 volts RMS. The volts in RMS, 3.535 volts. Now, I'm going to find the peak to peak voltage across the R1 resistor. The peak to peak voltage across the R1 resistor equals the 10 volt peak to peak times 100 ohms divided by 100 ohms plus 400 ohms. That equals 10 times 100 ohms divided by 100 plus 400 ohms equals exactly 2 volts. 2 volts peak to peak. So the peak to peak voltage across the R1 resistor, this one, is 2 volts peak to peak. Now I'm going to find the peak to peak voltage across the R2 resistor. VR2 peak to peak equals 10 volts peak to peak times 400 ohms divided by 100 ohms plus 400 ohms. That equals 10 volts times 400 divided by 100 plus 400. That equals 8 volts peak to peak. The voltage across the R2 resistor, the peak to peak voltage, is 8 volts peak to peak. Now I'm going to find the RMS current, the IRMS current. The RMS current, which flows through the entire circuit, equals IRMS equals the 10 volt peak to peak excuse me, that's wrong. It equals the 3.535 volts in RMS divided by 100 ohms plus 400 ohms. That equals 100 ohms plus 400 ohms. That equals 0.00707 amps. The IRMS current equals 0.00707 amps. Now the frequency out. We really don't need to do any math for that because this circuit is a purely resistive circuit. That means that the frequency on the output is the same frequency on the input. That means that it's 60 hertz here, 60 hertz here, 60 hertz here, which means that the frequency out is 60 hertz. Now, so this output voltage right here, where the 100 ohm resistor is 2 volt peak to peak. That means there is plus 1 volt here and minus 1 volt here, and this line in the middle represents 0 volts. So how do I get 2 volts peak to peak out of this? Because plus 1 plus or minus 1 equals 0. Well, this is what to do. You go 1 minus the plus 1 minus minus 1. That equals 2. On this side, you have 8 volt peak to peak. That means that you have 4 volts here plus 4 minus 4 volts here. And this line in the middle is 0 volts. So you go 4 volts minus a minus 4 volts. That equals 8 volts peak to peak. Up here is 10 volts peak to peak. There is a line running through the middle of this that equals 0 volts. This is plus 5 volts. This is minus 5 volts. So to find the peak to peak here, it's 5 volts minus and minus 5 volts equals 10 volts peak to peak. And notice that on the output, the voltage is the same shape as the input. That ends the video. Give me a thumbs up if I've helped you. Like and share, and subscribe. Thank you very much.